that look like? So 2 to the x, y, we can think of it as y equals 2 to the x. How could I write that as a log? Mason?
Like log base 2.
Yeah, or we could do it as y. So log base 2 of y equals x. Okay, so the base of the exponent, 2 raised to some x power, becomes your base of your log, and then you just switch those around. Okay, what is the domain of an exponential function? So again, thinking this f of x equals 2 raised to the x. What's the domain of that function again? Or if we thought of it graphically, what's the graph of an exponential function look like? Will it ever get down below the x-axis? Nope, it's always above the x-axis. What point is it guaranteed to cross through here on the y-axis? 0, 1. Okay, so we know it looks like this. This is the point 0, 1. So what is the domain of this function? So domain, again, is all x values. This is all real numbers, or you could say negative infinity all the way to positive infinity. Same thing. But then now our range of a log function. Okay, if I said that the inverse of 2 raised to the x is a log, and I said the domain of an exponential is all real numbers, what would be the range of the inverse? We talked about this last week too. Nope. Does anyone remember? Yeah, so this is still going to be all real numbers for the range. So inverse functions, domain and range switch. Okay, so if your domain of a function is negative infinity to infinity, the range of the inverse will also be negative infinity to infinity. Okay, so that idea that they are inverses of each other, if I know the domain of one, I automatically know the range of the other. Same thing, if I knew the range of an exponential function, that would be the domain of a log function. Okay, all right, so I'm just going to put this all up here. You don't have to write this all down. Okay, for one, I put these on Schoology, but you've already done this side. Okay, so you don't have to write that down. You've already actually written down that entire left side. Okay, so the general form of an exponential function, a to the x, it is increasing, and then it's decreasing if a is between 0 and 1. So if it was like half raised to the x power, we know it's actually a decreasing function. Number 3 gives you those 3 points that are always on a graph of an exponential function. The x-axis is a horizontal asymptote. It's never going to touch the x-axis. Domain and range of the exponential. Okay, now we're going to look at the inverse function, which is log base a of x. Okay, first 2 characteristics are the same. If a is greater than 1, then a is an increasing function. If a is between 0 and 1, or I'm sorry, f is an increasing function. If a is between 0 and 1, f is a decreasing function. But now specific points, okay? Instead of being negative 1 over a, it's 1 over a negative 1, which makes sense because we determined that these are inverses. And since they are inverses, the x and the y's switch. Instead of passing through the point 0, 1, it's going to pass through the point 1, 0. And then the third point, a comma 1, will be on the graph. So a log function actually looks something like this. Okay, so it's going to be in quadrant 1 and quadrant 4, and then it's going to be going down, where now y is, this should actually be vertical, not horizontal. y-axis is the vertical asymptote, and then domain and range again are switched from the exponential function. All right, so really these last three in blue are the key ones that you want to get. Everything on the left side you've already written down when we're talking about exponential functions. Okay, again, I'll put these on Schoology too if you need to fill in. All right, so compared graphically. So this blue line is going to be just an a to the x, and this is actually y equals 2 raised to the x power. And this is log base 2 of x. So you can just make a quick sketch on here, but I have it written out as specific points. So 0, 1 would be right here, 1, 0 would be right here. And again, because they're inverses, they reflect over that line y equals x. All right, so every single point is just going to be switched. So this is just, again, driving home the idea that logs and exponential functions are inverses of each other. But that's a good thing because we know every single point is just going to be switched. So if I know an x and I don't know a y, I can use one form to solve. Or if I know a y and I don't know an x, I can use the other form to solve. So they work together even though they are different functions, but you can use those to actually figure out what's going on. Okay, we can translate, shift log functions that follow the same rules. Okay, so this would be log base 4 of x. It's going right through our point 1, 0 right here. Well, now if I change it up to be log base 4 of x plus 2, anytime we are messing with that x and changing it up, x plus 2 actually shifts it to the left 2 units. Okay, I got in here plus, I don't know why I got an extra plus on there. I think I actually did this one as, yep, there should be a plus 1 on this function too. I was going to say, there's more going on. So this is really log base 4 of x plus 1, because this shifted over and then up 1. So just like all of our translation rules, if we're adding something after our function, it just moves it up or down. If it's within the function, it moves it left and right. Plus actually moves it to the left. So all of our translation shift properties hold true even with logs. Okay. All right. So here's the big thing for today. Here's some properties that you need to know. All right. First one is the power property. So if I have a log base a of x raised to a power, that power property allows me to bring that exponent r out front, and now it's r times log base a of x. if we want to do the log of 1, that's always 0, because remember, this is saying, this is really saying a to the 0 power equals 1, which is true. Anything raised to 0 power will always be 1. So log base a of 1 will always equal 0. And then base a log, or log base a of a, will equal 1, because this is saying a to the first power equals a, which is true. Okay, so all these three properties are useful or beneficial. That power property actually comes into play quite a bit. We have log base a of x to the r. We can bring that r out. We no longer have that exponent. And oftentimes that r will be a variable we're trying to solve for. So using logs allows us to bring that variable out from the exponent and then solve. And then these two, the product property. You can put them in parentheses or you don't have to, but I like to put them in parentheses for visual. Log base a of some product. So in this case, it's x times y. If you have a product, you can break it up into two logs with the same base of a and evaluate those separately. And this property can go both ways. So if you're given an addition piece where you're adding two logs together, well, then you could simply do one log and multiply your x and y. So those properties, you can use these either direction. And then if you have a quotient, some division going on, division turns into subtraction. And again, this goes both directions. If you have subtraction, you can rewrite it as a quotient of x divided by y. Okay, let's just do a couple examples real quick and you'll be off and rolling. So some properties, I had log base 9 of 15 divided by 7. Well, I just worked that out. That's log base 9 of 15 minus log base 9 of 7. And order is important. It's always numerator subtract denominator. So that is not equivalent to log base 9 of 7 subtract log base 9 of 15. So it's numerator subtract denominator every single time. We can have a radical in here where log base a of the cube root of m squared. Well, I know I can write that without a radical, and that would be m raised to the 2/3 power. My power rule says, well, I could bring that 2/3 down in front and multiply it. So this would be 2/3 of log base a of m. Even if they give it to me as a radical, no big deal, I can work with that. And I continue on cleaning it up a little bit, simplifying it to get to a point where I can work with. So you'll do some problems where you work with these properties, and then you'll also do some that they'll give you a big long expression with multiple logs in it, and they want you to rewrite it as one single log. Okay, order of operations is important here. Okay, when you're doing this simplifying, okay, we know we have our PEMDAS, and when we simplify, we go in this direction. So we want to simplify any parentheses first, any exponents, any multiplication. Can't spell the PEMDAS. There we go. Any multiplication, any division, any addition, and subtraction. So I want to simplify the addition first. So I'm focused on this right here. I'm going to tackle that first. And I don't want you to think it's absolute value, so let's put it in brackets. So this becomes log base 3. Both of them have the same base, so it's going to be a product now. So I can think of this as x times x plus 2. Now I'm going to take into account the subtraction. So order of operations is important. Don't do log base 3 of x, subtract log base 3 of 2, get that, and then multiply it by the first piece. But now because I have the same base, so this is log base 3, I have subtraction. This is x times x plus 2, all divided by 2. That would be final answer. You could multiply the x through on top, x squared plus 2x, or you can just leave it like this. Either way, it'd be fine. This is checking to see if you understand log properties, how you can rewrite as a single log. Got it? Okay. One thing I do want to bring to your attention too, on the very first day, or the very first slide, quiz Wednesday. I just moved it up from Thursday to Wednesday this week. So if you had written down the quiz was going to be Thursday, I just moved it up. It's actually going to be Wednesday. Some reason I had 4.4 over 2 days. 4.4 is only like 10 problems long. It's not that bad. Okay, so we'll do 4.4 tomorrow, and then we'll do 4.5, 4.6 to finish out the week. Quiz on Wednesday. I don't have any review or anything. Look back over the problems that we've done from 4.4 through 4.1. And that's all we'll do on Wednesday is we'll take the quiz, be on paper, and then Thursday we'll pick back up.
These are notes, right?
Do you need your notes?